Hello, it's Duncan. My recent experiments this spring have left me to question how much confidence we have that our test and production systems are wired the same way. I think that our naive functional approach to building the Gilded Rose app may have left some things working by coincidence. Sometimes functions hide too much information, so today we're going to look at refactoring from closures to classes. I said at the end of the last episode that I thought things needed tidying up. So let me explain why I think that is. Here's the entry point to our application. It creates a server and starts it. What does the server look like? Well, the function that creates it takes some parameters that define its operation. So which features we're using, how we're doing pricing, where we're reading from. These default to our production values and can be overridden here in test main so that when we're running a test version, we can see what's happening with pricing and so on. Now, it's all very well, but when we run our integration tests, we use this fixture here. And if I move that over there and compare it to server, you'll see that fixture defaults the same sort of things. So it allows us to configure the pricing and defaults to no op pricing, and allows us to configure the stock file, which defaults to a temporary file, and it allows us to configure the features, which it again defaults to normal features. But this being the way that we configure the system for our final tests before we ship it out to production, we'd like that to be as close as possible to production. And at the moment, it's just a coincidence that this no op pricing is the same as this no op pricing, and this features is the same as this features, and so on. So what we'd like to do, I think, is to have our integration tests as close as possible to our production system. So we'd like, in fact, to be calling the same method at some point as our main does in order to configure our integration test. And that method is our server here. If we did that, we'd have a lot more confidence that these hadn't got out of sync. And if we were creating a default fixture, we would be creating something as close as possible to the default production system. But the problem is that because this is just a function, the values of these parameters are just lost. They're basically captured inside this roots for and the server. They're captured inside a web of objects that is then run, but they're lost to us. When the parameters to a function are captured by a function that it returns, we call that a closure. I think this probably is a closure because if we drill down through roots for, we end up in listing. And you see here, we actually then pass the clock and the way we list into this function here, which actually just returns a function, an HTTP handler. This is very much a closure. We're returning a function that remembers the parameters to the function that created it. And so if we step back up again, this is itself a closure because it is returning a function. But we'd like not to lose that information. And so what we're going to do is we're going to create a class to hold it. And in Java, there's a refactoring called introduce parameter object. That doesn't exist in Kotlin, but we'll do it by hand here. What we're going to do is we're going to take these parameters and we're going to create a class from them. So we say we've got a data class, and these are the properties of the data class. We can just fill those in with a val. And we need to give it a name. And I think we're in the app, so we'll call it app. Now, inside this function, this statement has access to all of these parameters. But by the same token, if we were to create a method inside app and call it server, then that would have access to the same named things, but as the parameters. So in fact, we can just copy this code here and put it in there. And you see that compiles. I don't think I've run the test yet, so let's do that now. Good. Now, if we compare these two invocations of server for, you see a subtle difference, which is that these are not in bold and these are. And that's because these are the fields, whereas these are just parameters. So IntelliJ is formatting them a different way for us. Right, what we'd like to do is to make use of this app now. And what we're going to do then is we're going to replace this server for by a call to create an app and then ask it for its server. That should be the equivalent code. So this is going to be app given our port, stock file, features and pricing, and then ask that for its server. And as we know that this server is doing the same thing as the previous code was, when we run this, it should do exactly the same thing and pass all the tests. Now let's go to the call of the server and inline it so that they create an app and invoke server on it. So let's find them. There are two mains. If we inline this one, you'll see that we create an app with all the same overrides, and the same thing will happen here. We inline that one. Because the parameters are the same, that's been quite a nice refactor in that we haven't had to pass anything in here, and we're overriding the things we need to override in here. Let's go back to our app then. And what we could reasonably do now is make this into a property, and not with a getter, actually an initializer. So that's our server for our app. And then going back to main and test main, they both say server start. Well, we could delegate that to our app. So what we could say if our app had start, which does server start, then main could say app start, and test main could say app start. We don't actually call those from our tests yet, but let's just check it still builds by running the tests. Good. So now our app and our fixture are looking like they begin to have the same sort of shape. They both have a stock file. They both have features and pricing, which is good because what we'd like to be able to do is derive a fixture from our app so that our test code, instead of creating a fixture, creates an app with whatever defaults are there and overriding those that it doesn't want, and then uses that to get the fixture rather than calling this fixture constructor and then getting the roots out. So let's look at the other things that a fixture overrides about the configuration in roots. It changes the clock and it changes analytics. So I think we'll take both those things and make them properties of our app. This here, to our clock, I think would be nice that as a reference. And then we could pull that up into a parameter to our app class. We need to introduce a default value, and I don't know where this preview has gone. I think IntelliJ hates me. And for some reason, this has become a function type. We know what that actually means is something that takes nothing and returns an instant. And we're going to make that a val because it's a data class and we have to. Again, we'll run the test just to check this still compiles. Oh, it doesn't, because it turns out we needed the default parameter that wasn't put in by the refactor. So that should be instant now. Try again. Okay, good. And then the analytics, this defaults to this analytics here, which is currently in roots. That's a bit of an odd place. So I think I'm going to start by renaming this to be stood out analytics, just to give it a name that reflects what it does. It stood out because it uses println, which goes to stood out. I'm just going to take that out of here, and our app is in the same package. So I'm going to put it in there. And then finally, we'll take this, make a parameter. And again, we've lost everything about it. We'll call this analytics. And we do want a default value of that stood out analytics. There we go. Don't know why we haven't imported that, but we'll do it by hand. And again, have to say that it's a val. Check that all compiles by running our test. Okay, good. Now what we've done is we made everything that fixture wants to configure about the roots, parameters to our app, and in fact, properties of our app, so that we should be able to create an app with those properties and then use them to derive our fixture. That's the direction we're going in. So now what I'm going to do is I'm going to make a property out of these roots. So that's our roots. And that means we could tighten up the server. Why have I done that? Well, it means that we can create an app and ask for its roots, and the roots is the thing the fixture needs. That means that this can be create an app and then ask for its roots. The type is right, at least. And what should that app have? Well, it wants to be on the default port. In fact, the fixture will never start the server, so it doesn't matter. The stock file we want to pick out of here. So let's fill these in. We'll say the stock file for this app is the stock file for the fixture. The features for the app is the features for the fixture. The pricing for the app is the pricing for the fixture. The clock is what the fixture was using, which is just returning a single time of now. And the analytics is this analytics down here, this stood out analytics, and then add to the events. So if we write, this can go, and our test will still pass. Wonderful. And now instead of creating an app on the fly here, I'm going to make a property out of it. So that's my app. And that should again pass the tests. And now we want our fixture to have as little state of its own as we can. And it starts at the moment with this val stock file here, but then it passes into the app. So in fact, we could use that here as app.stockfile. And the same will be true here. This would be app.stockfile. Let's try that. And that breaks. And it breaks because we're creating the app here, but we're saving in an init, which happens before we create the app. Let's just move those around. That should get us running. Good. Now, in the interest of getting rid of state in fixture, I think this now can just be a parameter because it's only used here. Events we still need. Stock file, could that just be a parameter? Let's try. It can't be because we need to get it back out again here. That's not a problem though, because we can create ourselves a delegate. So we can say that it's file, stock file, and when we get it, we ask the app for its stock file. And in fact, that would allow us to say save to stock file and stock file. Let's see whether we're right. Good. Now, at the moment, we have a fixture that's building an app. But we said what we wanted to have was an app that builds the fixture, or at least be able to derive the fixture from the app rather than vice versa. And in order to do that, we kind of have to turn fixture inside out. Got no better way of putting it, really. What I'm going to do is I'm going to make this constructor into a secondary constructor. Let's see what happens when I do that. Then a bit importing, and we now have this horrible thing where we have events, which is a thing. Then we have a constructor, which assigns to events from here, then builds an app that's declared down here. It's all a bit horrible, but if we're right, it should be the same code. So let's just run it and see. Okay, well, that's a start. Now we know that the only real state the fixture has is these events and this app. The roots is derived from the app, so these are the two real things. So what I'm going to do is I'm going to put this into a primary constructor. So we'll take this, move it into here, and the same with the events, which are here. And having done that, this constructor can call the primary constructor with events and app. Now, this root is app roots. That I think we can just do down here and take that out. Just tighten it all up a bit so we can see more of it in one go. And check that it passes the tests. It does. Okay, so what was the point of that? Well, the point was that now we have a constructor. This constructor is really just a function. It's just calling the primary constructor of the fixture. So we should be able to take this code and make a function that does the same thing. I don't know that there's a refactor to do it automatically, so I'm going to write it by hand. So I'm going to say fun, and we'll call it new fixture for now. And that's going to take the same arguments as our secondary constructor. And it's going to call the same code. Well, what is the same code? Well, this is an invocation of the primary constructor. So this is calling the primary constructor on fixture with events equals events and app equals so on, this stuff. And then it's calling save with initial stock list, which is a parameter there. We can do that here with apply. And that's going to be the thing we return from this. So that's equivalent code, and we'll just make that into an expression body. This is currently unused, but if we were to call it fixture with a capital F, then it would clash with this constructor. But we could remove the constructor. And now our code would be calling our function rather than our constructor. This fixture one. Let's see whether that's true and it works. Well, that's nice. Again, why have we done this? Well, our aim was to turn the construction inside out, but we can't really refactor constructors very well, but we can refactor functions well. So now this is a function, we can refactor it to turn it inside out. Little reformat just to allow us to see what we're doing. It's worth at this point just seeing what changes we've made to the code around here. And the answer is, whilst we've changed the app and fixture and so on, we haven't actually changed anything that calls this fixture, creates this fixture. And that's because the things that were calling this, for example, this test here that creates a fixture, they were calling the constructor, and now they're calling a method with the same signature. And so they're unchanged. We'll actually be generating different bytecode, but we haven't had to update these in any way. Now for the turning inside out itself. I have to confess this has taken quite a while to work out how to do. Often I just go and edit the callers, but where a function is used a lot, if we can find a refactor that saves us typing and making error-prone mistakes, that's good. So at the moment, I'm still creating an app in order to create a fixture. What I'm going to do is I'm going to pull this app as a variable inside this function. Now I'm going to build in the app into two parts. First part I'll call base app, and that is going to have the things that are configured when we configure a fixture. So that is pricing and the features. The pricing is the pricing and the features, the features. And then this app we're going to form by copying bits of the base app and overriding them. So this is base app, copy. The stock file, we don't want to use this stock TSV. We want to use whatever's passed into the fixture. So we're overriding that. The features, well, our base app got the features from here, whatever we've overridden in when we call the fixture. So we can remove that. And the same with the pricing. The clock we want to override. And the analytics, we also want to override. But ideally, we'd use the base app's analytics rather than stood out analytics, although by default, that'll be the same thing. If we write, the behavior will again be the same and it will pass its tests. Let's just check. Good. We're almost there, I promise. What we're going to do now is take this and make a function out of it, also called fixture. This function finally then is a function that knows how to take an app created with whatever defaults we use over here and return a fixture. So what we can do is we can make this our receiver and inline this. And then finally, I'm going to move these defaults down into here. So that the stock file is defaulted and likewise our events. And that means that we don't need to pass the stock file or the events in here. We'll just name these to get it to compile. Now these are unused, so we can remove them. And again, just check that that doesn't break anything. It might have done if we were overriding them. So let's check. Well, it turns out we weren't, so that's good. Okay, finally, inline this. And now we're going to go to call it a fixture. Let's find one. Have a look at it here. If we inline this fixture, the invocation here, we need to make it public. Then you'll see that the parameters got put into the right places. So this got now an initial stock list put into the fixture, this call to the fixture here. That means we can go down here, fix this one. So now we're creating app with the default parameters and creating a fixture from it. Find some others. Here's one. So these were all places that we're using the defaults. So if we inline that, we're good. Inline that, we're good. This one here, however, is overriding pricing and the features. Let's see what happens if we inline it. They get moved into the app constructor, overriding the defaults from our production, which is exactly what we wanted. One more here. Check whether our inlining in list stock tests works. And it does. Find any that are left with the application events test. That creates a fixture. Inline that one. That's all good. And stock tests, likewise, that creates a fixture, which again will now be using our complete production defaults rather than defaults we're specifying in this function signature. Inline that. And now our fixture is unused, so we can remove it. And run. A little bit of a tidy up and a reformat, and check it all passes again. So let's just remind ourselves what we've done. Our production app was configured by this server function, which had some defaults, which we could override. And that created routes given those properties. Our integration test then needed to repeat that logic really in order to create routes themselves, because we didn't have a way of creating routes given the production logic. What we did was to create a class that represents all that configuration. And that class can yield routes for us and also is a nice place to put a server. And that means now that our fixture can be created from that class, from that app, overriding the things that it needs to interact, but it means that our tests can create an app with the defaults from production and then derive a fixture from it, rather than that being an accident of the parameters to this fixture being the same as the parameters to our initial server function. Well, that was quite an intricate refactor, and I don't mind telling you that it took quite a time to work out a nice route through it. But when we have lots of calls to things like fixture, it's often worth finding a way that we can automatically and safely refactor all the calls rather than go and edit them by hand. And a byproduct of this is that we've ended up with this class here, this app, which neatly encapsulates the important collaborators in our app. At some point, if our app gets big enough, we might need to split this into separate responsibilities, but at the moment it's nice to be able to look in one place, create one app, and then go pull the configuration out of it. In the next episode, I hope we'll be in a position to put the value of pricing into production. If you'd like to see that, then please subscribe to the channel using the link below. And if you enjoy intricate scripted refactorings, then I think you'll enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.